Let's look at a simple example applying our kinematic relationship for the torsion of circular bars. So let's consider a bar of length L, and we've measured the rotation to be phi of z equals a cosine 2 pi z over L. So a is a given constant, 10 to the minus 3. The length of the bar is 1,000 millimeters, and the radius of the bar is 20 millimeters. And the question is to find the maximum shear strain and its location in the bar. Okay, so this is a fairly straightforward problem. We know that the shear strain is always going to be r d phi dz in a circular bar. So I can plug in my expression for phi and take the derivative. I'll have minus ra 2 pi over L sine 2 pi z over L. And this is going to be maximized when r is maximized, so little r equals big R, and when 2 pi z over L is either pi over 2 or 3 pi over 2, so I get plus or minus 1 out of the sign. So I can plug that in, and I find, or solve for the z, I find that z is equal to L over 4 or 3L over 4. So those give me the two locations along the length of the bar, and the location radially is at the outer surface of the bar. So if I want, I can write down now that gamma max, the maximum shear strain, is plus or minus r, big R, times little a, times 2 pi over L. And if I plug in my numbers, I find that I get plus or minus 126 microstrain. And the locations where the shear strain takes on these maximum values are a quarter of the way down the length of the bar from either end, and for all the points along the periphery of the bar.